Today you are going to explain the difference between ratios, rates, and unit rates, and you're going to determine the rates and unit rates. We're also going to do playbook entries, and then you'll have practice activity. Here is a section of your playbook entry. You're going to need to open to page 285. Go ahead and take it out of the actual workbook. You're also going to need page 287 as well. Once you are done, you can close your workbook. We are not going to be using our workbook anymore, and you are not going to glue those pages at this time. All right, so you should have gone ahead and taken out the pages. We're going to go to the ratio. We're going to revisit what a ratio is here. A ratio is a multiplicative comparison of two numbers. And here I have examples where I have 2 out of 3. It's in words. Then I have it actually in my 3 different ways. Now remember, we can take a ratio because it can be written like a fraction, and we can reduce it even or convert it to a decimal, which sometimes the STAR test and some of your other exams will have. For a rate is a comparison by division of two quantities having different attributes. Now, attributes just basically means characteristics. So you are taking two different things and comparing them. For example, you're taking 36 miles in 3 hours. Rates deal in measurement and time. So it's not just time that you're going to have rates. You're also going to have rates in measurements, which you will see later on this week, if not next week. Here we have a unit rate. You can take a rate and make it down to a unit rate because a unit rate is a fraction that is written so that it has a denominator of 1. That is an N, not an H. So basically, a unit rate is a reduced form of a rate down to one denominator. So the denominator is always 1 in a unit rate. So here's just another example of a unit rate along with the definition. You'll notice that you can go from the rate, 15 characters in 5 seconds. The quotient, meaning our division part, is we're going to divide by 5 for both top and bottom. And then we get 3 characters in 5 seconds. So again, we went from rate to unit rate. Here's another example. This example actually is a nice example because we can actually determine it in 1 minute. We actually get a denominator of 1. This is an example where you do not get a denominator of 1. So here we have the Australian dragonfly can travel 18 miles in 30 minutes. It wants to know how far the dragonfly can travel in 1 minute. So you write the rate as a fraction. You compare the distance to the number of minutes, and then you divide. Well, luckily, the 6 can go into 18 and 30 to reduce it to 3 over 5. But a unit rate, because we're trying to figure it out in 1 minute, a unit rate has a denominator of 1. But if you notice, it says that the definition or the answer is that the dragonfly can travel 3/5 mile every minute. But I don't see 1 minute here. Well, that's because if we actually were to go from 5 minutes to 1 minute, I would be taking my 5 and I would be dividing by it, which means I would have to divide my 5 at the top. So I would then end up having 5 into 3. Now we know that 5 can't go into 3, so that's why we end up having to actually add our decimal and add a 0. And we put our copy of the decimal at the top of the quotient. So now I have 5 into 30. 5 into 30 can go in 6 times for an even amount of 30. So my answer is actually 0.6 in 1 minute. So basically 0.6 miles in 1 minute, or 6/10 of a mile in 1 minute, is 3/5. So 6/10 equals 3/5. So it is the same. So I want you to take a minute. I want you to try out some information here. See if you understand what it is. If not, then go back to the notes that you just took and see about rereading them. If at that time you still don't understand, raise your hand and I'll come and talk to you. Okay, so here is some of the information. For A, Emma downloaded 35 songs in 5 minutes. How many songs did she download per minute? It goes pretty easy. You divide by 5 and you get 7 songs in 1 minute. B is a little bit more involved. We started out with 9 cups of water to 12 cups of wheat flour, but it wants to know how much water was used per cup of flour. So we have to go down to 1 cup of flour. So that tells us what our denominator is. So I'm going from 12 wheat flour to 1 flour, or 1 cup of flour, which means I'm dividing by 12 if I set it up as a fraction form to equal it to the equivalent fraction. I divide by 5, well, here's my work down here because 12 doesn't go into 9 nicely. You have to actually add your decimal and your zeros. So it ends up being 75 hundredths cups of water, or it ends up being 3/4 cup of, cup of flour. So here you have your page, solve comparison problems involving rates. This is page 287. This just goes over a multi-step example of how to compare problems involving rates. Take a minute to just read over it for a little while, and that way you can get a better understanding. So here we have the question that represents solving comparison problems involving rates. Go ahead and read over it, and then I would like you to try out working it out. If you have any questions, raise your hand or refer back to the notes that you just read. The answer you should have gotten is 7,200 beats in 60 minutes. Because it's asking how many more beats does a hummingbird's heart beat in 60 minutes than a human baby's heart. Well, if you went back into the actual example above, it talks about how much or how fast a baby's heart beats in 60 minutes, which is 7,800. And then you have to convert the hummingbird's heart rate, which is 7,500 in 30 minutes, and make it over 60 minutes to compare the 60-minute heartbeat to the baby's heartbeat. Here you just have information about finding a unit price. So it does talk about money, where you're going from 1 ticket to 4 tickets, or you're going from 4 tickets to 1 ticket. So anytime you're going down to 1 as the denominator, but in specifically this one, it's talking about unit price. So now I want you to take a moment to just practice these problems here. I only want you to do 1, 2, 3, and 4. Don't do 5 and 6. So take a few moments, pause the video, and go ahead and set up the problems. Remember, only do 1, 2, 3, and 4. Right, so here are some of your answers. Number 1, you're setting it up 44 over 4. You divide by 4 and you get 11 points per quarter. For here on number 2, you set it up like a fraction, 125 feet in 5 seconds. You divide by 5 and you get 25 feet per second. Number 3, you have 360 miles traveled in 12 gallons of gasoline. How much in 1 gallon of gas, or how far in 1 gallon of gas? You divide, I put divide by 30. You are actually dividing by 12. And you are going to get, in 1 gallon of gas, you go 30 miles. Here on 4 is a little different. 4 is 12 meters in 28 seconds. And you want to go down to 1 second. So there's 2 things that you can do. you can take 12/28 and you can reduce it all the way down to 1 to find the unit price, which would be about 428 thousandths. In fact, it really just keeps going, but I stopped it at the thousandths place. Or you can reduce 12/28 to 3/7 by dividing by 4, and you actually get 3/7 per second, which is the same thing as this decimal point here, because this decimal point is roughly this right here in fraction form. So either way, you can do one or you can do both. Now you're going to take your information that we've gone over and you're going to cut, or not cut so much as fold and glue. Here, this tells you to take page 285 and you're going to fold along the yellow line, that's this one right here, and then you're going to glue down this section. Then you're going to take page 287, you're going to fold on the green line, and you're going to glue this section down. That's because I want to make sure that you leave this section to show in case you need any of that extra help. Please remember that this is going to be a little smaller than what you have left to flip open, so you want to make sure that you glue it in the correct spot in your paper or on your playbook. Once you're finished gluing, you're going to move on into the next slide in Nearpod that's going to tell you what to do next.